Hello friends, welcome to my channel. Let's have a look at problem 605, can place flowers. This is today's daily challenge problem. In this video, we're going to share some solution formats based on simulation. So this problem is marked as easy by LeetCode, and however, this problem is interesting itself. Here, we are given a array called flower bed. So containing zeros and ones. 0 means empty and 1 means not empty. And also we are given the integer n. So we want to see if we can put this n new flowers to the flower bed with the constraint that there are no adjacent flowers. So here are two examples. So in example 1, so there are 3 consecutive zeros, so we can place one flower in between, in the middle. So this is true, return. And in example 2, so if we want to put 2 extra flowers, so we are going to produce adjacent flowers, so this returns false. The constraints for this problem are the following. First, the list flower bed can have a length up to 2 times 10 to the power 4. This is a decent large number, we see, and this is a binary list, and also there are no 2 adjacent flowers in the flower bed. So this is an important assumption. And the last one actually is a consistency assumption. For example, if you have a length n, if you want to place more flowers, say more than half plus 1 or plus 2, depending on if it's end, even or odd. So for sure that's impossible. So with that said, let's look at some analysis. So here the problem is very straightforward. Let's look at some examples, hopefully helping us to establish intuition. First, so if you have ones into, you can imagine this A is a segment of the long flower bed. So in this segment, you have ones in the two ends, and there's 1 0. So you cannot place any new flowers here. So if you even have 2 zeros, still you cannot place extra flower. So this is the 2 example. So let's look at example 1. So now if the 2 ends are ones, but in between there are 3 consecutive zeros, you can place 1 extra flower in between. And if there's one set, there are ones, so you can put here or in the end. And there's some consecutive zeros, then you can start from here. So you can put 1 here, 1 here, 1 here. You can place 3 more. So similarly, you can look at examples. They're beginning with consecutive zeros and ending with consecutive ones. You can regard this as a segment of the long piece of flower bed list. So in this example, you can place 3. So in example 1 and example 2, I placed zeros in both ends, just to hint that in our coding we are going to use this small trick to help our iteration or index check. So in example 3, so this is just to help establish intuition. Assume that we have an empty flower bed, meaning all the elements are zeros. So if the length is even, so basically we can place the integral division by 2 and plus 1. So this here we can place 2, right? You can place at 2 ends. In other words, put in the even index 0 and 2. And if we have an even length, right? So we can put into the even indices, so 0 and 2. Or we can put into odd indices, 1 and 3, and both give us 2, right? So once we know this, I guess writing the code is sort of straightforward. So here we are going to give 3 solution formats. Essentially, they're the same solution, but sometimes slightly different formats do help understand the logic or help establish intuition. First, I'm going to do this. So I'm going to I have already changed this flower bed to be A. This is just for the ease of typing. So here let's initialize a result variable, not result variable. Let's count variable. So basically we want to count how many extra flowers we can put into the flower bed. The logic is that if we can put no less than n flowers, right? So also I'm going to introduce the length of this A, right? Oh no, let's do this maybe first. I can add 0 and then A and 0 in two ends. That's just for convenience. Then we get the length of this A, the new A. So this length is 2 longer than the original length. Then you are going to realize why we add two zeros in the two ends. Next, we are going to do the iteration. So we are going to iterate for I in range. So we are going to iterate from index 1 because the index 1 is the new A corresponding to the first element in the original A. And then I'm going to up to list ls minus 2. So we write ls minus 1 here. The reason is that we can check I plus 1 and I minus 1. So with this range, so let's do the check. If A, we're going to check the current position. If this I is not equal to 1, so in this case, it means that we might be able to put a flower here, and then the condition is that the two neighbors, left and right, are empty. So we want to check if I minus 1 is not 1, and I plus 1 is also not 1. So these two expressions, I minus 1 and I plus 1, justifies the action operations here, right? And this makes sure I minus 1 and I plus 1 are both in bound. So if this is the case, so we can increment the count by 1, and then we can set the current index element to be 1. So this is the basic logic. If we finish the for loop, basically what we get is that we can put this count number of extra flowers. So what we want to do is just to compare if count is no less than the given n. This is the A solution format. So before we do any comments or proceed, let's do a check. Yeah, it passes a cooked up example. Now let's look at generic case. Yeah, it passes all the cases. So notice that in the previous tries, so we need to pay attention to the return format. This is returns a boolean. So originally I was trying to return count itself. So this is one version. So here actually up to now, so if count is larger than or equal to n, we don't need to finish the for loop. So we can add an early stopping condition. So here we can add if count greater than or equal to n, so we can return true. So this is also good. Let's do a check. Yeah, it's much faster, right? So with that said, so no, let's say I want to make an extra comment. So it's much faster due to the early stopping, but the time complexity does not change. It's still O of n. So with that said, let's slightly change our sort direction. I'm going to copy this this part, and let's copy the whole code. And I'm going to change this one to be version v1. I would like to do some slightly modification just to reverse the thought process. So here we have this one, we have length. So the iteration is the same, right? So basically, what I'm going to do is I don't need this count variable even, right? What I want to do is that if this is the case, means that we can put a flower here. So basically, we reduce n by 1. So the thing is that we just need to make sure if n can be less than or equal to 0, right? We can reduce n to be 0. So here, after we do this, we can do a check immediately. So if n less than or equal to 0, we can return true. So otherwise, we just set this a of I to be 1. And then essentially the same, return n less than or equal to 0. So this is like the reverse, it's the same, but this is v1, now this is v2. Now let's do a check first. Yeah. This is the second solution. So now I'm going to copy this part again and write another solution. But here I'm going to use a for loop. So I'm going to use assignment like what we did. So first I'm going to append a element at the end, right? Just at the end. So I'm going to do this, append 0, right? And then what we're going to do is because in this way I just want to check I plus 1, so I use this append 0. So here I initialize to be 0, and then I'm going to use the length to be length of the current a. So notice that this length is 1 longer than the previous one. So and then we are going to set I to be 0. So what we are going to do is val I less than length minus 1. So basically, I want to check if we can place flowers or reduce n. So here I'm using reduce n from the second version. What I'm going to do is the following. So if the current element equals 1, it means that we cannot place flowers in the next position, right? Then we are going to increment I by 2. This is one case. Other case, if the current position is empty, then we're going to check if the next position is empty or not. So if the next position is not empty, then we know the next position cannot place flower, and also the next position cannot place flowers. Then I'm going to increment this I by 3, right? Otherwise, in this else block, we know AI is 0 and AI plus 1 is also 0, right? And then what we're going to do, we can reduce m, and then we're going to set the current position to be 1, and then we're going to move I because the current position is set to be 1, and then the next position cannot place flower, so we are going to increment I by 2, right? And then the thing is that we just need to return finally if n is less than or equal to 0. So this is another solution format. So we are starting from one position. You can think of this example 3, right? So let's do a test first. It passes all the cases. So again here, so we don't need to finish all the list if there's a list stopping condition. So if n less than or equal to 0, we can return true. So let's test again. Yeah. So I guess that's about it for this specific easy problem. In this video, we shared a solution essentially based on, I would say, observation. So here I'm using simulation, just a wording. And then we presented 3 solution formats. So the first one is based on counting how many extra flowers we can plant. And the second version based on reduce n to check if we can reduce it to be 0. And the third one basically is a one direction. We check from left to right. So if you like, you can check from right to left by adding a 0 at the very beginning, right? And iterate reversely. So with that said, I guess that's about it for this video. If you are interested or you find the explanation here helpful, you can check out our channel in YouTube for more coding practices. So with that said, I guess that's about it. Thank you.